Okay students, next property of D block elements is formation of colored ions. See, most of the ions and compounds, that is compounds of transition elements, are colored both in the solid state as well as in the aqueous solutions. See, a substance acquires color if it can absorb radiation in the visible range of approximately 400 to 760 nanometer. White light, consists of different color components. When wavelengths corresponding to certain color are absorbed from the white light, the transmitted light contains wavelength corresponding to the other colors. These colors are called as complementary colors. The color which is observed, that is the color which is transmitted, is called the complementary color to the color absorbed. So the substance will have the complementary color. The observed color will be the complementary color. The color which we observe is the complementary color. See, when metals in case of isolated gaseous metals, that is in the isolated gaseous atoms, in the atomic state, all the 5 d orbitals of the metals, they are degenerate. That means they have same energy. But when the ligands approach the metal, what are ligands? About ligands you will study in coordination compounds. When the ligands approach the metal, the 5 degenerate d orbitals will split up into 2 sets of orbitals, that is lower T2g orbital and higher Eg orbitals. The lower T2g orbital includes dxy, dyz and dxz, and higher Eg orbital includes dx square minus y square and dz square. See, when the ligands approach the metal, the 5 degenerate d orbitals will split up into 2 sets of orbitals. So when when visible light falls on the transition metal compound, the electrons which are present in the lower T2g orbital will undergo excitation to higher Eg orbitals. That is by absorbing radiations from the visible light. See, this transition elements contains vacant d orbitals or incompletely filled d orbitals. Hence, there is space, there are vacant spaces for the electrons to undergo excitation. In the higher energy state, they have vacant spaces. Hence, they undergo excitation by absorbing radiation, that is frequency of radiation from the visible light. The energy which is absorbed is equal to the energy difference between 2 sets of orbitals. Thus, the ion exhibits the complementary color of the absorbed radiation. This, that is, when an electron from a lower energy d orbital is excited to higher energy d orbital, the energy of excitation corresponds to the frequency of light absorbed. This frequency generally lies in the visible region. The color observed, the color which we observe, corresponds to the complementary color of the color absorbed. One color is absorbed, that is the radiation is absorbed, that is the color is absorbed. The color observed will be the complementary color of the color absorbed. The frequency of light absorbed is determined. The frequency of light which is absorbed is determined by the nature of ligand. So, if we see in aqueous solution, that means in aqueous solutions means water molecules acts as ligands. In aqueous solutions, the color of some transition metal ions are given in the table. See, if the configuration is 3D0, that is, for example, scandium 3 plus has 3D0 configuration, it is colorless because no unpaired electrons, no, it is a vacant d orbital, it has vacant d orbital, so no dd transition. The transition of electrons from lower T to G to higher Eg orbitals is called as dd transition. So no dd transition can take place here, so no color will be exhibited, so the compound will be colorless. Then if we consider titanium 4 plus, this also has 3D0 configuration, this also is colorless. Then titanium 3 plus, if we consider, it has 3D1 configuration. Then unpaired electron is there, it can undergo excitation, so one of the light it absorbs, and the color exhibited, that is the complementary color, the color we observe is the purple color. Titanium 3 plus has purple color. Then vanadium, similarly here the colors of some of the transition metal ions are given here. See here, when the light falls here, first one, when the ligand approaches the metal ion, the d orbital, the degenerate d orbitals, degenerate means having same energy. Degenerate d orbitals will split up into two sets of orbitals. These two sets have different energies. The lower energy T2G orbital and higher energy EG orbital. So T2G contains three orbitals, dxy, dyz and dxz, and EG, higher energy EG orbital, contains two d orbitals, they are dx square minus y square and dz square. Here, when the visible light falls on the transition metal ions, the unpaired electrons, they undergo excitation from lower energy T2G orbital to higher energy EG orbital by absorbing radiation from the visible light. The one of the light it absorbs, the remaining colors will be transmitted. The color which we observed is the complementary colors of the color absorbed. So here you see how to find the complementary color. The complementary color can be known from the chart given here, from the complementary color chart. The complementary color will be the complementary colors are found placed diagonally opposite. For example, if red color is absorbed, the transmitted color is green color. If red color is absorbed, the diagonally opposite color, as you are seeing in the chart, is green color. So the green color is observed. If red color is absorbed, then the transmitted complementary color, that means the color we observe is the green color. Some more examples we can see. If radiation corresponding to yellow color is absorbed, then the complementary color will be violet, that is purple or violet. Because the complementary color will be, the transmitted color will be a mixture of blue and red color. So the color appears violet or purple. And one more example, if wavelength corresponding to red color is absorbed, then the transmitted light will be bluish green color. And the substance appears bluish green, as you can see in the chart. If green color is absorbed, the complementary color becomes red. You can see in the chart.